In this video, we're going to learn how to simplify expressions with rational exponents. So sometimes exponents will be in the form of fractions, and the key here is that the denominator of that fraction is a radical with an index that matches that denominator. So for example, if I had a square root of 36, that's the same as 36 to the 1/2 power because the index of that root would be 2. The cube root of 64 is the same thing as 64 to the 1/3 power, and the fourth root of 16 is the same thing as 16 to the 1/4 power. You'll notice that the index goes right to the denominator when you switch forms. So if I wanted to simplify this expression, 216 to the 1/3, I would rewrite this as the cubed root of 216 and then further simplify. That cube root came from that denominator of 3. And now 216 is the same thing as 6 to the 3rd power. So the cube root of 216 is actually equal to 6. So 216 to the 1/3 power is 6. Now an alternate way you could solve this problem is without even changing the form, you could rewrite this as 6 to the 3rd power to the 1/3, and then you can multiply the exponents. They give you 6 to the 3 over 3, which is the same as 6 to the 1st, which is 6. So that's another way you can go about simplifying rational exponents. Next up, we have 7 to the 1/2 times 7 to the 1/2, which can be rewritten as the square root of 7, because the denominator is 2, that's a square root index, times the square root of 7. So the square root of 7 times the square root of 7 is the square root of 49, which is 7. And then again, an alternate way to do this is if you multiply these together, you can get 7 to the 1/2 plus 1/2 whenever you multiply two numbers with a common base. And that gives you 7 to the 1st, which is 7. So again, lots of ways you can work with it, but again, the denominators represent radicals. So if I see here I have 7 to the 1/2 and 21 to the 1/2, well, I can't use that method where they combine the exponents because the bases are different, but I can rewrite it as the square root of 7 times the square root of 21, which when multiplied together gives me the square root of 147, which I could further simplify because I have 7 times 21, which 21 is 7 times 3. So I do have a 7 squared within 147. So I do have a 49 times 3. So that gives me 7 square roots of 3 when simplified. And if you wanted to look at this as the alternate method, you would have to rewrite 21 as 7 times 3, and then distribute that 1/2 power in. And it gives you 7 to the 1/2 times 7 to the 1/2 times 3 to the 1/2, and then you'll see, okay, I have 7 to the 1/2 plus 1/2 times 3 to the 1/2, which is 7 to the 1st, times 3 to the 1/2, which will give you 7, and then square roots of 3. So again, you can work with the exponent as well. Now here I have 3 terms being multiplied, but all the bases are -3. So this is -3 to the 1/3 times -3 to the 1/3 times -3 to the 1/3, which I can rewrite as -3 to the 1/3 plus 1/3 plus 1/3, which gives me -3 to the 1st power, which is just -3. Now I have 5 to the 1/4 times 125 to the 1/4. So these are fourth roots, since the denominator is 4. So I have the fourth root of 5 times the fourth root of 125. When multiplied together, gives me the fourth root of 625, which 625 is known as 5 to the 4th. So the fourth root of 625 is 5. And another way to get to this answer using those exponents, I could rewrite this as 5 to the 1/4 times 5 to the 3rd to the 1/4, which 5 to the 3rd is 125. And then I can multiply 3 times a 4th. So I get 5 to the 1/4 times 5 to the 3/4, then add those exponents together, which gives me 5 to the first, which is 5. Lastly, I have 3 to the 1/2 times 12 to the 1/2, which I can write as the square root of 3 times the square root of 12. Multiply together gives me the square root of 36, which is 6. And I could go a similar method as you saw before by rewriting this as 3 to the 1/2 times 3 times 4 to the 1/2. So distribute the 1/2, I'll get 3 to the 1/2 times 3 to the 1/2 times 4 to the 1/2. This will become 3 to the 1/2 plus 1/2. And then 4 to the 1/2 is the same thing as the square root of 4. So I can get 3 to the first times the square root of 4, which is 2, which would lead to 6 as well. So many pathways, but you have to understand when you see a fraction that represents a radical expression. And that's how you simplify expressions with rational exponents.